This is an activity on parallelograms. The objective of this activity is to verify that the areas of parallelograms, two parallelograms in this case, on the same base and between the same parallels are equal. Let's study this concept in detail first. So suppose you have a line L and a line M which are parallel to each other, and we have taken 2 points on M, A and B. Using A and B, we draw a parallelogram on the base AB where C and D, they lie on L. So if you join like this, ABCD will be a parallelogram. Now if you take two more points, say P and Q on L and join them like this with A and B, there will be another parallelogram ABQP. So the parallelogram ABCD and the parallelogram ABQP, they lie on the same base AB and they lie between the same parallel lines L and M. Therefore, the areas of these two parallelograms will always be equal. That is the concept in hand. And now let's see what material we have to use to conduct this activity. We need a wooden board, some nails, knobs, a circular elastic string, wooden strips, and gum for pasting work. Let's perform this activity now.
So in this activity, I have taken a wooden board and I have pasted a graph sheet on it. As you can see, we have drawn two lines L and M which are parallel to each other on the graph sheet, and I have marked 2 points A and B at a distance of 6 units from each other. Likewise, I have marked points C and D on the upper line, that is L, which are at a distance of 6 units again from each other. At all the 4 points, I have fixed pins and I have fixed a rubber band like this, thereby showing the shape of a parallelogram. So if you want to find the area of this parallelogram, you can just count the number of complete squares inside this. You can ignore less than half squares which are coming inside and take more than half as one, and then count the total number of squares in the parallelogram, which will give you an approximate idea of its area. Likewise, you can shift the parallelogram by shifting the pins. You have to keep the base exactly same AB. Only thing is you can shift the point, like if you shift the point D to this point E and you take this point as the new point F, you will get another parallelogram ABEF. You can again count the number of complete squares inside and you will find that the area of ABC DC and ABEF both will be nearly same. You can keep on changing the upper side of the parallelogram, but take care that the length of this side should be equal to the length of the upper side. And if you fix the rubber band accordingly, all the parallelograms which you will get as the common base AB will have the same area. And that proves that whenever there are multiple parallelograms between the same parallel lines L and M and on the same base AB, they are of equal area, and which completes our activity.